Hi everyone, this is Mark Schuyler. I'm here today to talk to you about Pythagorean triples. Some math teachers are a little cutesy and refer to them as Pythagorean triplets, but whatever you call them, triples, triplets, they are right triangles. Remember, the Pythagorean theorem only works on right triangles. But some right triangles are more famous than others. For example, the most famous right triangle of all is no doubt the 3, 4, 5 triangle. That's an example of a Pythagorean triple because there are integer values on all three sides of the triangle, both legs and the hypotenuse. So obviously the hypotenuse is the longest side of a right triangle. You have to keep that in mind. The legs can never be as long as the hypotenuse. So if you have a leg of 3 and you have a leg of 4 and it's a right triangle, you don't actually need to go through the Pythagorean theorem to figure out what the hypotenuse is. This is an example of where you should recognize, just like you would recognize a famous celebrity, and who wouldn't recognize, I'm going to date myself here, someone like Angelina Jolie or Brad Pitt. If you see the 3 and you see the 4 on the legs, you know the hypotenuse is a 5. That's not the only Pythagorean triple. In fact, any multiple up from the 3, 4, 5 triangle is also a Pythagorean triple. Let me give you an example. The SAT seems to be testing the next multiple up from the 3, 4, 5 very, very much. It's the 6, 8, 10. And the 6 is just a doubling of the 3, the 8 is a doubling of the 4, and the 10 is a doubling of the 5. And so that triangle is a right triangle. And again, if you should see the SAT presents you with a problem where there's already given to you a leg of 6 and a leg of 8, you shouldn't have to go through the trouble of squaring the 6 and adding it to the square of 8, and then coming up with the sum of 100, and then finding the square root of 100 to determine that the hypotenuse is 10. No need to go through that. Plus, of course, there's always the chance of a blunder, some small error with the fundamental operations creeping in, that instead is just sight recognition. Oh, that's Angelina Jolie. That's the 6, 8, 10 triangle. There's another Pythagorean triple that you should be aware of and have sight recognition of. It's the 5, 12, 13 triangle. And if this triangle is drawn to scale, it would look rather like a doorstop. It might only be 5 inches high. Not that a doorstop would be 5 inches high. It'd be one heck of a door. But it would have a height of 5 and a very long base of 12. Quite elongated, and then a hypotenuse of 13, which notice is just 1 unit longer than the longest leg, the 5, 12, 13. So it's a big time saver to recognize the 3, 4, 5 or the 6, 8, 10 or the 5, 12, 13. I had a student ask me, what's the big deal about Pythagorean triples? Why does the test maker obsess with them and test them so often? The answer to that question is most right triangles do not have integer values on all three sides. If you just construct a random right triangle, the chances of it having integers all the way around very slight, very small. Most right triangles have square roots on 1, 2, or all 3 of the sides. So it's actually quite remarkable and interesting and aesthetically pleasing when a triangle actually does have integers all the way around. If you've worked with geometry a bit and with triangles a bit, you would be aware of these very aesthetically pleasing and interesting triangles. So I think that's the rationale behind why the test maker is a little more interested in seeing, hey, does the student recognize these and can solve them quickly without even really needing to do the Pythagorean theorem because you're so familiar with them. So I hope that helps, and I hope it is a time saver, and may you find a few 3, 4, 5, 6, 8, 10, and 5, 12, 13 triangles lurking on your next SAT, and you can solve them quickly and easily. Thanks. Bye now.